Hey, g'day, it's Brezo here, back in the shop today. This is another episode of some of the upgrades I've been doing on my Bridgeport mill. And since I got the mill running again, I've been looking at sort of adding some accessories and trying to improve the functionality of the machine. Now these are 3 aluminium scales that came off the Bridgeport head. This one is the Z-axis travel on the quill. This one is the tilt on the head, so it's tilt sort of forward and back. And this is the tilt for the head left to right. Now all 3 of these are pretty badly beaten up. This one's not too bad, but it's a bit damaged on the edges. This one's sort of a bit beyond redemption really. It was all bent over on itself when I got it, and I've removed that and flattened it out. And this one's actually split in the middle. So it's sort of not real good, and I thought about buying brand new replicas of these, and you can get them, and you can get the original ones, the original Bridgeport parts, but just at the moment the shipping time is a bit outrageous, and I thought I could probably make my own. Now, just to prove that some parts can be purchased, this is a brand new one. This is the tilt scale, the forward and back tilt scale, and this one came from China. And I don't know if you can see that, but when I got it, it was dented and bent just here, and it's made of the most flimsy, thin aluminium, and it's got a self-adhesive back, but I can't imagine that lasting very long on the head of the mill. So I don't think I'm going to use that. It's a bit rubbish really. But when I thought about trying to make these for myself, I thought, well, I've got a CNC milling machine, I've got a drag engraving tool, and I've got plenty of stock. I've got plenty of aluminium and stainless steel. So I set about doing some experiments. Now this is one that I did on the drag engraving, or at least the CNC mill with the drag engraving tool. This is aluminium sheet, and I drew the artwork for this scale on my computer. I use Corel Draw, and just by measuring and doing a bit of CAD work, I was able to get a pretty, well, it is an accurate replica of that scale. And what I did was I drag engraved through the aluminium, and then I powder coated it, and then I rubbed off all the powder coat. And my intention was to get something that looked pretty close to that. Now, it's not bad, but I'm still not happy with it. It's sort of not as clear as I would like, and where the numbers match up, like the 0 here for example, it doesn't quite join up, so I wasn't happy with that. Then I tried using stainless steel. Now this one, I haven't rubbed all the powder coat off, but I did enough to be able to tell that that's not really going to work either. Now the stainless steel being harder, the drag engraving tool doesn't quite penetrate as deeply, so we don't get quite as much black powder coat into those marks. And with this one I used a type of font called a Cambam stick font, and this has a single outline with no fill. So it's a lot clearer, the zeros match up perfectly, so I'm very happy with that. But still, there's not enough contrast in that to really work. All right, I'm going to try a slightly different approach with this. I've got 3 pieces of aluminium here, and each one of these will take one of those scales. So I think that one goes there, this one will fit on there, and these are all oversized of course, that one on there. And what I'm going to try to do is to anodize this material in black and then drag engrave through the black anodized coating to expose the shiny aluminium underneath. So in reality we're going to get the negative, or the reverse of what we got now. So we're going to have a black scale with light engraving on it rather than what we've got on the originals. Now I know this works. You get a really, really good contrasty finish to it. It's durable, the anodizing will protect the material, and it should last indefinitely. Now the choice of material is really important here though. Some grades of aluminium anodize more easily than others. The one that I'm using here is a pre-anodized aluminium sheet. And this stuff has got that sort of eggshell finish on it. If you get a scriber and you scratch that coating there, you'll hear it sound like a bit like chalk on a blackboard is probably the best way to describe it. And you can feel that it's sort of got a hard coating that you can get through, and then you get into the underlying material, which is a lot softer. The only thing is that you can't anodize this directly. You have to first of all get the original pre-anodized coating off, and you do that by soaking this material in a solution of sodium hydroxide or lye or caustic soda, and you basically fizz all that coating off and get back to the raw aluminium. Now you might say, why choose this material if you got that extra step? Well, the reason is that I know that I can anodize it. And some grades of aluminium, you go to all the work of doing the anodized process, and then you go to dye them and they don't take the dye. So at least I know this is a known material and I know it will work. So as far as the surface prep goes on these, I've sanded them with a bit of 320 grit sandpaper. Then I followed up with a red Scotch-Brite, and I'm just trying to get a sort of a uniform grain finish on that. Now these are about to go into the anodizing bath, and I'll bring you back when I've got the black coating on this, and then we'll have a go at the drag engraving. Is it going to work? I don't know. We'll give it a go though. Here's one of those parts straight out of the anodizing bath, and we'll put it into this dye here. Now this is a Caswell dye. It's a new one that I got just recently, and this one's called Black BKXL. Supposedly it gives you a really deep black, consistent black. In reality, I found it takes about half an hour to 45 minutes in a heated bath, and this is heated to 60 degrees C. And this is one I've put in about 5 minutes ago. Yeah, that one there. So it's starting to turn, but we'll leave them for about maybe half an hour, 45 minutes. The long strip that I made will have to go into a different shaped bath. It's not going to fit in here. Eventually found this old toolbox which is just the right size, and I've had all the parts in here now for about an hour. And there's one that I've rinsed off. It's not jet black, certainly not what you'd normally see in a black anodized aluminium part. They're normally a jet black colour. This is sort of slightly translucent, but I think it's going to be suitable. We'll get a good contrast when we drag and grade through that. But I'm going to leave this now overnight. I'll turn the heat off and I'll just let it soak in there, and we'll check it out tomorrow and see how black it actually goes. Well, here's our anodized stock now, and I left this in overnight and it went a lot blacker, a lot darker, and quite happy with that. This one here, this long one, there's a bit of a watermark in the center there, and that's because when I put it into the cleaner solution I had to leave one end in and then turn it over to the other end, and it's left a strange sort of a lightish mark in the center there, and we're just going to have to live with that. But these two here have come out quite uniform. Really happy with that. And what we need to do now is to put these in the CNC mill and drag engrave all of these marks that you can see on here, as well as the perimeter of the actual scale. Now, just to be sure that I've got this right, I've drawn all of these out and then printed them on paper. Now clearly you don't want to go to all this work and then engrave something on this material and find out that it's not actually dimensionally accurate. Now this scale here, this is fairly straightforward, this one, because each of these marks, each of these divisions is exactly 1 millimeter apart, and with any sort of vector drawing program that's really easy to do. And I was able to measure the original here with a pair of calipers, get the width and the length correct. I could measure the offset to the 0, get that pretty accurate, and then when you print it out on paper you can put the original scale over the top and just verify that everything lines up. So that's easy. So this longer scale, a little bit different. These are not millimeter marks. These are radial marks, 1 degree apart and 10 degrees at the major divisions. And because of the circumference of the finished scale, this works out to be some strange measurement with 2 decimal places. So when you're laying this out, you know, it's a bit of trial and error. And of course what you need to do is get this on paper first, and then put the original back over the top, and then check that everything lines up, and not just at say 10 degrees, but you want to come right down here to the 70 or the 80, and make sure that they do line up accurately. So I'm happy I've got that correct. And with this one, now I had a bit of a bet each way here, and I've cut one of these out. Now this is just a rough and ready one, but once again I wanted to be sure that each of these degree increments is accurate compared to the original. So this one was probably the hardest one to do, because there are very few reference marks on the machine to actually get this radius here and this inner radius, and also the end points and so on. So it took a lot of messing around to get that one right. But I'm pretty sure I've got it correct. So let's go ahead and get these engraved now. One of the good things about this drag engraving process is that it places very little cutting force on the material itself. So it doesn't take a lot to hold it down to the bed of the CNC mill. So I'm just going to use a couple of screws and washers here. And you could probably use some double-sided tape or hot glue or something like that. I'm just going to put one in the middle here. I've offset this so that there's no chance I can hit the screws with the engraving bit. The other good thing is that because of the spring-loaded nature of the stylus in the drag engraving tool, is that if this is not dead flat, it doesn't matter. And it's not like a rotary engraving tool where the depth of cut will vary if this is bowed. The spring takes care of any sort of undulations in the surface of that material. Now this is the one we're going to do, and I'm going to position my origin so that the engraving will take place in this half of the stock here. So like I say, I don't want to hit these with the stylus. Okay, let's get it set up and we'll go from there. So I've got the stock bolted down to the table, and this is a Sieg X3 milling machine, been converted to CNC. And the tool that I'm using is a drag engraving tool I got from a company called Boring Research. And this has got a brazed carbide tip, and I've done a dry run at Z10 just to make sure I wasn't going to hit anything. And I've used my top right hand corner here as the origin, and I put the original scale there just to make sure I got everything in the right place. So let's get rid of this, give it a go. What can go wrong? I must say I'm super happy with that. The clarity is excellent, and there are some little bits on the surface there, and they are just swarf. That's just where material has been raised up and broken off by the stylus. But other than that, I'm really super happy with that. There are some burrs, and they're mainly down this edge here where the millimeter scale reaches that perimeter, and there's almost nothing I can do about that. If you were to try and remove those burrs now by braiding or sanding or anything like that, that will also remove the anodized coating, so we're just going to have to live with that. As it turns out, that edge doesn't matter because we're going to cut that back when we removed the scale from stock, so they will disappear. It's the ones on the numbers and maybe on the inner edge of those divisions that we're going to have to live with. Now, you would have noticed, I think, that this stock was flexing up and down a bit, but it makes absolutely no difference to the engraving. And you would have also noticed that the order at which it did all the engraving was a bit weird, and I don't know why that is. It's something to do with the software I'm using. It's called Kanban, and it seems to make up its own mind about where it goes, and I think there's a way of reordering the cuts, but in this case it doesn't really matter. The interesting thing was when it drew the perimeter, it started here and it did a full run around and finished up there. Now that's where I get a bit nervous, because if your ball nuts are not super accurate on your machine, you're going to notice a discrepancy at that point, because it's done 2 Y travels, and if there's any backlash at all, it's going to show up where those points meet. But I'm happy to say that's worked out spot on. Okay, let's get this off now and we'll do the next one. Just being a real chicken here and doing a dry run, just so there's no nasty surprises. I've only got one piece of this stock, so I've got to be sure it's right. Don't you like that noise? Well, again, I'm really happy with the contrast and the clarity of that engraving. This started rather abruptly though. I meant to have the Z axis elevated 5mm to do a perimeter check to make sure I wasn't going to run off this edge. And as you can see, I got very, very close to it, but I escaped disaster there. And the big problem is that if the stylus drops over an edge, and because it's spring-loaded, it would drop downwards, and then if it keeps moving, it's likely you're going to bend or break something. But I got lucky there, and what we need to do now is do the final of these, which is the very long strip, and the challenge there is going to be how I hold that down. This one's a bit of a technical challenge because my stock's not as big as I'd like it to be, and holding it down is a bit of an issue, so I've used double-sided tape here, and I've done a dry run. I've got just enough room around the perimeter, so let's give it a blast. Set my Z properly. Yeah, let's try it. Well, there you go, and I just realised it didn't engrave the 90 at this end, so what went wrong there, Mark? You idiot. Okay, I need to go back and look at my original artwork there. I've obviously overlooked something. if I leave this, I don't touch anything, I can just engrave that 90 and hopefully get away with it. Alright, let's try that again. I've actually written another G-code to just put the 90 on this end. I checked the original artwork and the 90 was there, but it didn't copy over to make the DXF file. When I put it into Kanban, I just overlooked it. Anyway, let's do this one now. There you go, crisis averted. Just so I didn't make a complete fool of myself on camera, I went ahead and cut this long scale out of its parent stock, and I've sanded the edges on a belt sander, and I've just deburred that with a sanding block and some fine sandpaper. So now that I know how it works, I'll go and show you how to do these two. That looks a bit ugly, but we'll clean this up on the belt sander now. Well, unfortunately I didn't get the last bit, but basically what I did was go around the top of the contact wheel there and just hog out the back of that material. And you've sort of got to be super vigilant when you're doing this on these straight edges at least. And what you're looking for is that engraved line to just disappear, and then the black shows against the grit of the belt. So that one there has been fully detailed around the edge there now. I'll need to deburr it a little bit more. But overall, super happy with that. Let's have a look at where it's going on the mill. As you can see, there are 3 drilled holes in here, and they originally had drive pins or drive rivets or whatever they're called in there. And when I put the new scale on, I'm going to have to be very, very careful to get the 0 mark directly opposite this scribed mark here. Now, I've already trammed ahead, so I know that that 0 mark is correct, so I'll need to make sure this lines up perfectly. And of course the challenge is to get the drilled holes in this part to match up with the underlying holes in the cast iron head. And I don't know, I'm sort of half tempted to stick that on with double-sided tape, you know. No, I better not. I was a bit lucky that this old arc scale was still reasonably accurate, even though it was a bit beaten up and damaged on the ends. And all I did here was I clamped these 2 parts together and I transferred the drill holes for the rivets through. And I've already drilled that now, and that's ready to go back on the machine. So that's where we're going to go, and I've already checked this just to be sure that the zeros line up. So remember, the head's already trammed, and I did have the opportunity to make these holes slightly oversized to get a little bit of vertical movement if I needed it. but I'm sort of happy that I've got that right. So let's put this back on. So I'm just going to get these pushed in partially, just as a double check. And these are the original rivets that I was able to get out without damaging them. Scale came off second best. Alright, so that's sort of held on there. You can see that it's still a bit loose and it's very, very close to this 0 mark. These scales are not meant to be super accurate anyway. I think the idea would be that once you tilt it over to, you know, ballpark angular dimension, you should then use a dial indicator and some sort of angle block to dial it in. Anyway, let's just drive these in gently. Alrighty, that's it. So that's on. Let's check out the next one. With the Z scale here, I replaced the original screws that were in here with some socket head cap screws, and I know they're not original, but the screws that came with the machine were mismatched anyway. One was brass, one was steel, and these just look a bit nicer. Is that a word? Nicer? More better? Okay, that's done. I know this screw head covers up the 100 mark, but hey, that's how it was on the original. And well, we're all grown-up people. We've got a grasp of basic mathematics, so we can work it out. Anyway, that one's done. Let's look at the last one. So this last one I've rolled that on the jeweler's roll, just so it conforms to the circumference of that casting there. And if we line up the 0 mark, which is there, we should be able to put our little rivet in on the top first. So I'm just going to tap that one in loosely. And the other one's underneath. So I'll get that one in and then we'll have a look at the finished result. Oh, that's on there now. It's pretty firm. Got a little bit of movement there. Not sure what that's about, but there's only 2 rivets holding this on, one at either end. So maybe I should have used a double-sided tape. I'm not sure. But anyway, there's the 0 right opposite the mark. So pretty happy with that. Overall, I love the look of this. I got a lot of black on the machine anyway. So having the black scales with the bright graduations seems to work out for me anyway. So there you go, that's how you make your own graduated scales for any machine basically. And yes, you do need a CNC milling machine, but a CNC router would work. So if you've got one of those little woodworking routers, you could use exactly the same technique for that. And the drag engraving tools are not ridiculously expensive. The one that I purchased, I think it was like $100 or something like that by the time I got it here. But truly a versatile tool, and you can use it for not only making this sort of thing like graduated scales, but for marking out on metal as well. And it's just another tool that you can use if you're doing machine restoration or new builds. So there you go, that's it. Thanks for joining me. I'll see you on the next video. That's Prezzo signing out. Catch you later.